Chapter 21, Think and Explain. Number 35, as pitch of a sound gets higher, what happens to the frequency? I have issues with this and the fact that it implies a different cause and effect. As the frequency gets higher, the pitch gets higher. As the pitch gets higher, it has to be supplied by a higher frequency. Other than the cause and effect, their pitch and frequency go together. 36, your classmate. Notice it doesn't say your friend, because your friend would automatically be wrong. Your classmate says the timbre refers to the quality of steady music sound composed of a mixture of harmonics of different intensities. Do you agree or disagree? Agree. The timbre comes from the actual composition of the materials and more the geometry of the shape. So that becomes crucial. So it is a whole bunch of stuff involved. 44, a nylon guitar string vibrates in a standing wave pattern as shown in the figure. What is the wavelength? All right, so remember that a wave will go up, down, and then back to the starting point again. So this wave right here is 1.5 waves. So 90 centimeters is 1.5 wavelengths. And so a wavelength would be 90 divided by 1.5, which is 60. So 60 centimeters is the wavelength. 47, thicker or thinner of the two guitar strings. Remember that the speed of a wave on a string is equal to the square root of the tension over the linear density. So if I have a thicker string, presumably made of the same material, a thicker string would correspond to a higher mass per length. In other words, a higher linear density. That fraction of tension over linear density, if my denominator gets smaller, if my denominator gets bigger, then my fraction gets smaller. So the sound will travel faster, or the wave will travel faster in the thinner guitar of the two guitar strings, assuming the same length and tension. So the wave travels faster, and therefore you would have a higher frequency. So the wave's traveling, and the thing's going to vibrate. So it'll go there and back. Faster, you get the standing pattern more easily. 54, two musical notes displayed one at a time on an oscilloscope screen, which has the higher pitch. The one with a longer wavelength will have the lower frequency and therefore lower pitch. And so the one on the left, you have a smaller wavelength. The peak-to-peak distance is smaller, assuming that they're on the same scale. If the peak-to-peak length is smaller, then you have a smaller wavelength, higher frequency, higher pitch. Which displays a louder sound. Louder has nothing to do with frequency or pitch for the most part. There are some biophysics involved there, but the higher the amplitude, the louder the sound. So the one on the right would have the louder sound. 58, one person has a threshold of hearing of 5 decibels, another has 10 decibels. Which person has more acute hearing? They both have great hearing. Usually humans can't hear below, I was thinking of something else for a moment there. So let's go drop back. 58, person has threshold hearing of 5 decibels, another 10 decibels. This deals with the intensity of the sound, and 5 decibels is less intense. And if a person can hear that as a threshold of hearing instead of 10, that the 5 decibels has much more acute hearing. Why does your voice sound fuller in a shower? So this comes down to, it's not that the water doesn't have to be going with this one, although some have tried to make an argument for it. It's primarily that bathtubs are surrounded usually by tile or some sort of solid piece of plastic, and you get that reverberation. So the sound bounces off of that, echoes, and so you have the two sounds sort of joining each other. And so you not only get your own voice, sound from your own voice, you get the sound from the other one, from the echo. Now, in theory, I guess you could get a position where you have destructive interference, but that's just not likely to happen. Your brain doesn't process it. They would have to be perfectly matched up for your brain to process it as no sound, and that would just freak me out if I was making sound in the shower and suddenly it sounded like nothing. Perhaps someday. Anyway, that's it for the Think and Explain from Chapter 21.